On This Week in Enterprise Tech, India got breached. Yeah, no, the whole country. Lenovo gets a slap on the wrist for Superfish. Fort Collins wins their own net neutrality. And Meltdown and Spectre give us a headache while IBM drops in to explain microservices. Twice on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twiet, This Week in Enterprise Tech, episode 272, recorded January 5th, 2018, Microservices in the Enterprise. This Week in Enterprise Tech is brought to you by IT Pro TV, the fun and entertaining way to sharpen your IT skills. Visit itpro.tv/enterprise and use the code ENTERPRISE30 to get a free 7-day trial and 30% off a monthly membership for the lifetime of your active subscription. Welcome to Twiet, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT pro, and the geek who just wants to know how the world is connected. I'm your host, Father Robert Ballasare, the digital Jesuit, your guide to all things in the enterprise. But of course, I can't guide you by myself. I've got to have a couple of my friends, starting with Mr. Brian Chi. He is the director of the Advanced Network Computing Laboratory in Honolulu, Hawaii. He is just home after an almost month-long cruise/Disneyland Wonderland thingy vacation. Cheebert, it's good to have you back, my friend.
Hey, man. So this is the Christmas gift. It goes on top of my iPhone. It's awesome.
Do you now have a portable podcasting rig?
You bet.
Oh.
And the best part is it works with the Mevo. So I can actually I can stream to the phone. The phone can mix the audio in, and that way I can shove a mic in someone's face, even if it's nice, noisy. And it's pretty awesome.
Well, you know, and now, like toys.
And the Mevo is now shipping in 1080p, 60 frames per second.
Wait, now you have to buy a new one, or you can update the old one?
No, I actually asked in no upgrade path. I even say, dude, I was a super early adopter. You should give us props. And he goes, no, sorry, we can't. No, not even a discount.
Oh, well, Cheebert, we're not here to talk about Christmas gifts. That comes later. We're going to be doing all the news. Plus, we've got IBM coming on to talk a little bit about microservices. You're going to want to stay tabbed for that. Before we get to that, though, happy freaking New Year. That's right, folks. It's 2018, the first show of the new year. We got to say hello to all of our most loyal listeners. That's Emily the Strange. That's JJ to the 4884. That's Loquacious One. It's Boz, Webster, Reverb Mike. Great to see you all back in the chat room. And Cheebert, let's kick it off, as we always do, with the blips. Now, when Yahoo got breached, it was a comical head smack. When the OPM was breached, it was a sharp but persistent pain for thousands of government employees. When Equifax dropped its breach brick, it was a real financial danger for hundreds of millions. So what do you call a breach of a government system that contains critical personally identifying information on a billion people? I don't know, but the people in India do. According to the Indian newspaper Tribune, the personal information of over 1 billion Indian citizens has been exfiltrated and can now be bought online for less than £6. That's about $8. The information seems to have come from the Aadhaar database, which contains full names, addresses, emails, phone numbers, photographs, and biometric information, including thumbprints and retinal scans. For the past 4 years, Aadhaar has been sending its workers across the country to gather information from Indian citizens to create a database for the Unique Identification Authority of India, or UIDAI. The thing is, this report, though not independently verified, is not a surprise. The Aadhaar database has been breached several times by the government itself. Though the UIDAI continues to claim that the database has never been breached and the available information must be a fraud, more than 200 government-run websites that were tied into the database have been found at one time or another to have exposed database information to the public because of bad coding, conflicting policy, or out-and-out ignorance. To be clear, though, this is a learning moment for everyone in IT. They're dealing in real time with the challenge of designing, creating, and maintaining a massive database of extremely sensitive information that needs to be at once secure and instantly available. Stay tabbed and stay learned, because you might be given that impossible task in the future.
Well, congratulations to Fort Collins, Colorado for beating the cable lobby and kicking off their municipal broadband project. The city council in Fort Collins, Colorado last night voted to move ahead with the municipal fiber broadband networking project, providing gigabit speeds 2 months after the cable industry failed to stop the project. Well, last Wednesday night, the city council vote came after residents of Fort Collins approved a ballot question that authorized the city to build a broadband network. The ballot question, passed in November, didn't guarantee that the network would be built because the city-county approval was still required, but that hurdle is now cleared. Residents approved the ballot question despite an anti-municipal broadband lobbying campaign backed by groups funded by Comcast and CenturyLink. What's really significant in my mind is that the Fort Collins plans on making their municipal broadband truly net neutral. And I say congratulations to them for this David versus Goliath battle.
Now, not too long ago, Lenovo was called out for pre-installing what they called a search assistant on its Windows PC sold in the United States, but what was actually a slightly modified version of a man-in-the-middle adware injector called Superfish. The Lenovo installation included a universal self-signed CA, which allowed it to scan even encrypted SSL traffic, and the certificate privacy key was the same across all laptops, which meant it was a trivial process for a third party to access, read, copy, and modify supposedly secure communications. They got found out, it was embarrassing, and the FTC put a significant amount of its manpower to bring Lenovo to justice. Now, more than 3 years later, we've got the FTC version of justice. Lenovo has to pay a $3.5 million fine to be divided between 32 states, and super-duper swearsies not to do it again on the PCs that they sell in the United States. Specifically, they are required to A, get the consumer's consent before installing software, B, provide instructions for the removal of that software, and C, provide a reasonably effective opt-out policy. Unfortunately, there's no bite to this judgment. About $100,000 per state is a drop in the bucket, and the wording of the punishment is at best vague. And the enforcement, well, it will be handled by an outside company that will work for and get paid by Lenovo. Sadly, this impotent signposting is about what we've come to expect from the FTC, which, by the way, is now responsible for making sure ISPs don't do bad things.
Sadly, Comcast fires 500 people, even after promising to create new jobs as a result of the promised tax break. Comcast reportedly fired about 500 salespeople shortly before Christmas, despite claiming that the company would create thousands of new jobs in exchange for a big tax cut. Comcast apparently tried to keep the filings secret while it lobbied for the tax cut that was eventually passed into law by the Republican-controlled Congress and signed by President Trump in late December. The Philadelphia Inquirer revealed the Comcast firings this week in an article based on information from an anonymous former employee, Comcast documents, and other sources in the company. The former employee who talked to the Inquirer could not be identified because of a non-disclosure agreement as part of the severance package, the article said. The Inquirer headline notes that Comcast was able to implement the firings quietly, avoiding any press coverage until this week. Man, talk about the Grinch that stole Christmas for 500 families and possibly the rest of the United States.
Okay, so maybe Comcast is being the Grinch that stole Christmas, but the other ISPs must be spreading job joy, right? After all, FCC Chairman Ajit Pai removed those nasty job-killing privacy policies that would have required ISPs to inform customers that they were selling their data, and he overturned the even more job-killing government regulation that was net neutrality. Pair that with the billions in tax cuts that ISPs will reap from the new tax code, and Comcast has to be the exception, right? Well, not so much. AT&T, which reported $39.7 billion in revenue on $6.4 billion in operating costs in the last quarter, has announced that they also will be laying off employees. However, while Comcast is laying off salespeople, AT&T is laying off technicians. There's no comprehensive numbers yet, probably because AT&T was hoping that their $1,000 bonus for all workers would mute the news of the layoffs, but it will probably be somewhere north of 4,000 workers. Indianapolis alone will be losing 12% of their installation technicians. AT&T's response to the bad press has been puzzling. One representative suggested that the layoffs were done according to attendance records, while another said it was done according to seniority. An official spokesman yesterday blamed the layoffs on, quote, changing market dynamics, unquote, and promised that some technicians will be offered jobs in other markets, though early indications suggest that the new jobs are in sales in AT&T stores. So not a great fit for a technician.
So continuing my rant, gee, awesome. My senator and I think alike. And we're both saying, turn your rage at the FCC into votes. Seems the Congressional Review Act, aka the CRA, empowers Congress to use a resolution of disapproval to overturn rules passed by federal agencies, and to pass it only requires a simple majority in both the House and Senate. In other words, it may still be possible to prevent the rules enforcing net neutrality from being dismantled without enduring a year-long legal battle in the U.S. Court of Appeals. So instead of raging in social media, rage at your Congress critters and demand they support a resolution of disapproval for the actions of the FCC in killing net neutrality. Now, I am going to say that our friend JJ to the 4884 did provide some really interesting counterpoint on how Ajit Pai's actions might actually help the net. However, sorry, man, I still have my doubts that Ajit Pai is really going to be able to pull off his grand plan. And even after looking at the counterpoint, and it sounds like, okay, maybe it might actually help things by making it easier to make some changes. I don't know, man. Jury's still out. And, sorry, JJ, I'm still going to rant at Ajit Pai, and I'm still going to say, rail at your Congress critters, get them to consider a resolution of disapproval.
Now, okay, let's pull back a little bit, because we know it's been a rocky year for the FCC and the public. After all, they've removed privacy protections, net neutrality, the fight to make set-top boxes more fair, and sided with the industry against municipal broadband initiatives. But all of that was done in the name, as JJ to the 4884 has suggested, of giving more choice to the consumer, more ability for the ISPs to give consumers the services they wanted, and for the market to decide. They're still at the service of the people, right? Right? Under Section 706 of the Telecommunications Act, the FCC is tasked with monitoring broadband speeds to ensure that they're being deployed to all Americans in a reasonably timely and uniform way. The previous FCC set broadband standards at 25 megabits per second downstream and 4 megabits per second up. Unfortunately, ISPs have done a horrible job of deployment and are nowhere near those standards. So what to do? Drop net neutrality so that ISPs will invest in infrastructure? Lobby for a change in the tax code to give ISPs billions in tax relief and incentives for deployment? Well, if you're this FCC, you do both of those, but then you also change the standard so that ISPs can take that money and do no deployment. FCC Chairman Ajit Pai has announced that at their February meeting, they'll be voting to change the broadband standards from 25 down, 4 up to 10 down, 1 up. As if that wasn't enough, they're also including wireless service to count against the deployment standard, meaning that if you can theoretically get at least 10 megabits per second down, 1 megabit per second up from a wireless carrier in your area, incumbents are not bound at all to deploy in your area. They're also dropping the affordability clause in the current language, meaning that if your home or business can theoretically get 10-1 in any way, shape, or form, you meet the standards, even if that would cost you tens of thousands of dollars for your monthly. That does it for the blips. Next up, we've got the bites, and we've got to do a deep dive on something that's been nagging the back of our brains, and that is, what do you do with bug bounties? What's the responsibility for manufacturers, for companies, to make sure that researchers are looking out for them? But before we get there, let's go ahead and take a moment to thank the sponsor of this episode of This Week in Enterprise Tech. Now, this episode is brought to you by IT Pro TV. With the new year comes new resolutions. Now, whether you're looking to jazz up your resume or you're considering an exciting new career in tech, make your professional resolutions a reality this year with IT Pro TV. IT Pro TV offers 3,300 hours of on-demand training with more than 125 hours added weekly. You can stream IT Pro TV courses live and on demand worldwide via Chromecast, Roku, Amazon Fire, Apple TV, PC, and by using their iOS or Android apps. Now, one of the things that sets IT Pro TV apart is that it does IT live every day, so that you'll know you're getting the most current IT training. Their courses include Certified Ethical Hacker, Kali Linux, Linux Security Techniques, ITIL, ISC2S, Security Certs, and more. Now, be sure to check their calendar for upcoming courses so that you can, drop in on the classes that interest you. You can advance your IT career and prepare for the certifications that you're interested in. CRISC, CISSP, CISM, CISA, and CEH, all included with IT Pro TV's individual memberships. You can also check out IT Pro TV's team solution for group pricing and access to the IT Pro TV Supervisor portal. Now, speaking of teams, this portal is the perfect solution for team leaders who need to make sure that their team members stay current. With the team solution, you gain full control of your team's training schedule, letting you create custom groups and training assignments and see individual and group analytics. You can view logins, viewing time, video downloads, course completion, and more. Join the more than 85,000 IT Pro TV members today. Check out itpro.tv/enterprise and find out how IT Pro TV can offer you or your team the best IT training solution. You're going to get a free 7-day trial when you sign up for an individual monthly membership using the offer code ENTERPRISE30. You'll also receive 30% off your subscription for the lifetime of your active subscription. Now, if you're interested in learning more about IT Pro TV's team solutions, you can also sign up for a free demo of their supervisor portal. Just go to itpro.tv/enterprise. That's itpro.tv/enterprise and use the code ENTERPRISE30 to try it free for 7 days and receive 30% off. Friendly training, binge-worthy content, life-changing results. And we thank IT Pro TV for their support of This Week in Enterprise Tech. Let's get back to it. We're going to be talking a little bit about bug bountings and ethical hacking. Now, we've had guests on this show in the past talking about bug bounties, but an example just came up, and I think it merits some of our attention. Now, here's what we know. There's a security researcher with the handle of Seguza, and he discovered a local privilege escalation in LPE that gains a local attacker root access. Now, the flaw is in the IOHID family Mac OS kernel driver. Anytime the system is in logout mode, that means on a log-on screen after a log-off, a reboot, or a shutdown, it becomes vulnerable to the LPE. Now, Seguza released to public without informing Apple. This kind of turned a lot of heads because that's not the way that we do it. The acceptable, responsible way to release such information is to give the manufacturer a heads up and then a period of time so that they can fix and patch. However, Seguza didn't do that. And he actually explains his reasoning for not doing what we would call responsible disclosure. He stated 2 reasons. 1, the vulnerability could not be implemented remotely, and therefore he felt that the threat was actually low. And 2, Apple doesn't offer a bug bounty on Mac OS, so he was not incentivized to do a reasonable disclosure. Cheebert, let's start with that. Actually, a pretty basic example. This is what security researchers do. They poke around, they prod, they look for things that are broken that they can take advantage of. There's a lot of furor on both sides of this. You have some people in the security research world who are saying, this is irresponsible, you don't do this. If you want to be respected, you always have to follow the rules. And then there are others who are saying, wait a minute, Apple has a bug bounty program, but they didn't include Mac OS. They only included iOS and their other products. So if the company itself is not willing to incentivize someone to do responsible disclosure on their part, then can they actually expect responsible disclosure? What are your thoughts?
Well, actually, I think normally I'm not real wild about rumors, but I keep hearing from lots and lots of different sources that Apple is actually even worse than doesn't provide incentives for bugs on Mac OS. The stories I'm starting to hear is that they actually disincentivize people. I keep hearing this one example being passed around within a lot of the press saying that someone actually did try to inform Apple and then got sued because of it.
Right.
So considering the arrogance that I keep hearing about Mac OS and Apple and how they handle bugs, I actually don't blame them. I think Apple needs to learn how to play better. I think bug bounties are actually a lot more important than a lot of people, say. I'm going to steal a little bit of your thunder here. Because Imperium Labs, the guys that did Stage Fright, you know, inform Google early on. It was very responsible, and their bug bounty was only $1,337.
Which, by the way, is leet. In leet speak, that's
yeah.
The bug bounty was actually supposed to be 1,000, but they kind of bargained it up just so that they could have that 1,337. So good to them. Oh, sorry, continue.
Yeah. But if it was on the black market, the dark net, man, those guys could have made millions, if not tens of millions, on that particular hack. Lots and lots of money. But they were awesome about it, and Google was awesome about it. So I'm sorry, Apple, you guys are a little hard to deal with. Maybe you might want to seriously consider, even though you keep poking fun at Microsoft, their bug bounty program is actually pretty decent. Padre and I both have this really cool coin that, they gave the press. We could have traded in for a drink, but neither of us really drink that much, and the coin was really cool.
It was a nice coin, yeah. The bug bounty coin.
But personally, I think we really ought to do responsible disclosure. Seguza, sorry, man. I think you could have done it a little differently, but I don't blame you. I've had to do a lot of different types of fighting with Apple, and there is sadly a level of arrogance that it just makes it really hard to talk to them.
Yeah.
So, I don't know.
This is why I like this story, because it's not a cut and clear. I'm more with Emily the Strange in the chat room, who's right now. She's saying, wait a minute, no. We hold ourselves as IT people, as responsible internet citizens. We understand that there is the right way to do things. And the right way to do things is you protect your fellow users. And the way that you protect your fellow users is you always do responsible disclosure. That's not an option. That's something that you do because you are a good person. And I get that. And I hold that. And I'm more on that line than the others. On the other side, can these companies really expect to get something for free? I mean, they benefit from bug bounty programs. They benefit from any bugs and exploits that are responsibly disclosed. But if they're not willing to give back to the security researcher community, if they're not willing to at least have guidelines, even for maybe not money, but for exposure, so that people can build up their names and looking for these bugs, then they're not incentivized. In fact, they're incentivized the other way. If someone spends tens, hundreds, thousands of hours looking for exploits inside of code, and then can either give it away for free and never be mentioned, never get any rewards, or get reimbursed for those tens, hundreds, thousands of hours via the black hat side, then, I mean, it's kind of hard to fault them, right?
Yeah. I'm sorry. I think you get a lot better results from a carrot than a stick. And, come on. The guy that found this, Seguza, literally by finding it, probably saved Apple, couple hundred hours, couple thousand hours of developer time? Come on now. Even at minimum wage, for heaven's sakes, give the guy some props.
Yeah,
or girl, but whoever Seguza is.
That's right. That's right. We should make that gender assumption. However, okay, let me do devil's advocate. I'm going to back off a little bit and bring us back to the bad old days. Go back 10, 15 years, and you'll remember, you alluded to this in your first response, that at one point in the security researcher industry, the nascent industry, if you discovered vulnerabilities, you could almost guarantee that you would get sued. Almost guarantee that they'd come after you. And I think we've gone past that. And there's sort of a detente between those people who find the holes, those people who patch the holes. So I could see an industry expert. I could see someone at Apple saying, well, if you're not going to do responsible disclosure, we're just going to go after you because you've violated at least the 1996 Computer Fraud and Abuse Act, because we can bend that to say anything we want. This way, we're giving you the opportunity to do the right thing. Is that a compelling enough argument to tell someone who is deciding between a payoff or responsible disclosure that they should go with the responsible disclosure?
Dude, if that was the argument, I'll put on a black hat and an eye patch. If people aren't going to be at least willing to give me some props for my talent, if I can't use it on my resume, I'm going to make some money.
Yeah.
Sorry.
Yeah. Okay, and we'll leave it there. You know what I want to do? I've been trying to swing a couple of black hats and gray hats to come on the show. Of course, there's obviously some concerns about that, but it would be nice to get a real world perspective on what they think they're doing, because a lot of them don't think they're being black hats. They just turn out doing that. Before we move on to our guest, because I do want to save as much time as possible for our guest, we do have to discuss one other story, one kind of big story right now, and that is the fact that we've got Meltdown and Spectre. Now, if you haven't been listening to the news, then you don't know about Meltdown or Spectre, but if you've heard any sort of news, you know that there were two major flaws discovered in microprocessor architecture this last week, at least disclosed to us. They were discovered months ago, and Intel, Microsoft, Apple, basically all the partners up and down the platforms have been racing to find a way to patch this. Now, Meltdown only affects Intel processors, and basically they've got a kernel memory leak. You may know that inside of a processor, there's protected memory in which the kernel is going to do its operations, and you don't want anything to be able to have visibility into that because, well, if they have visibility into the kernel, they basically own everything. Well, Intel has admitted that there's a slight problem in that it leaks, and that an attacker can, in relatively short order, figure out exactly what's in that protected memory. And if they find out what's in that protected memory, they basically own everything. Now, that has been a little bit of a controversy with them patching it, because Intel has recognized that there could be between a 5 and 30% performance hit to implement the patch. And essentially what the patch does is it takes that memory and it separates it from everything else, but now you're running overhead on top of the processor. That's always a bad thing. Now, they make the right argument that most users will not notice any difference, because most users have their processors sitting idle most of the time. So you're not going to notice that little 5 to 30% overhead. But Chibert, and this has been big in enterprise circles, the enterprise has been very good the last couple of years in maximizing efficiency and only spinning up processors when they can be maxed out. So the fact that I can now have a rack of computers in an Amazon data center or in a Microsoft Azure center that are going to take a 5 to 30% hit, that's not just an inconvenience. That's a major financial meltdown, excuse the pun. What are your thoughts here? I think Intel is right in that consumers won't notice the difference, but the enterprise is going to be screaming bloody murder.
Yeah, well, hey, I've got a rack of Intel Blade servers and I've got a rack of AMD Blade servers. It's going to be really interesting to see just exactly whether or not that 5 to 10% hit is an underestimate or an overestimate.
Now, the funny thing is, before the announcements, there were some interesting murmurs in the background channels of IT of people who were saying, hey, you know, my AWS cluster is going a lot more slowly. It's chugging along. My operations aren't running as quickly. I'm having to allocate more resources. So some people have already experienced the hit. And of course, it's going to depend on what you're doing. If you're a regular user, again, no notice. If you've got something that's high processing rate and high I/O, especially high I/O, you will feel it 100%. Now, the question for me, Chibert, is we've seen this before. You may remember, if you wind the clock back 20 years, something like this happened in the Intel x86 line. They found 4 instructions, 4 simple hexadecimal instructions that when sent to the CPU would crash it. And they didn't do anything. They basically just let the hardware expire and people bought new processors. Will that happen again? Are they just going to expect the data centers and the big enterprise players to suck it up and pay for the new processors when they come out? Or do you think there's going to be an actual financial impact this time?
You know, I don't know. But I actually make buy decisions for a reasonable number of servers. And I'm almost thinking, gee, you know, Cavium's coming out with some really interesting new ways of handling HPC clusters.
Right.
And AMD's, you know, I've been able to buy AMD-based servers for one heck of a lot less money than Intel-based. I'm starting to think that maybe, just maybe, Intel just managed to breathe a heck of a lot of life back into AMD and Cavium.
Right. Well, yeah, exactly, because this only affects, Meltdown only affects Intel chips.
Right. And if I was Intel marketing, I would then say, hey, you know, oops, sorry. Tell you what, you're gonna need to upgrade anyway because things in the enterprise move really, really fast. If you have one of the effective CPUs, we're gonna discount it for your upgrade.
Right.
I think that's about the only way that I can think of that Intel's going to be able to save their market share on this one.
Yeah. And unlike 20 years ago, where most of the enterprise players were desktops and it wasn't really worth it, the big enterprise players now have huge data centers. And it does make sense for them to go after Intel and to say, hey, we've got literally 40,000 faulty processors. You're going to have to cut us a deal or this is going to go to court. Very interesting to see how this is going to shake out. Now, let's do another quick blurb on the other flaw that was found, because it wasn't just Meltdown, there was also Spectre. And Spectre is both scarier and not as scarier at the same time, because it doesn't just affect Intel chips. This is going to affect all chips, AMD, Cavium, et cetera, et cetera. And that is the way that branch prediction is done. And unfortunately, on most CPUs, branch prediction is done the same way. They've discovered that although it's not going to affect the protected memory for the kernel, with the broken branch prediction, I can now have applications inside my memory poking around the memory, the supposedly protected memory of other applications. Now, again, the impact on this isn't as great because you don't get access to the kernel. However, it is greater in the sense that it works everywhere. It's going to work on Intel chips. It's going to work on AMD chips. It's going to work on ARM processors. Now, this one is weird because I get Meltdown. I can patch Meltdown. There's no real easy way to patch Spectre. There's no real easy way to fix branch prediction. So in your mind, Cheeber, which is the more dangerous of these two?
Well, you know, it's flip a coin, dude. You know, obviously there's a bigger surface area on Spectre than obviously Meltdown. But writing that level of code, we're still talking severe needing of LEET. You know, this is not easy code to write. And a toolkit for this isn't going to be forthcoming anytime really super soon. So, okay, I'm going to flip a coin and say I think Meltdown's actually going to have a bigger impact just because the enterprise is going to freak out and say, hey, make us a deal. So financially, I think Meltdown's going to have a bigger impact than Spectre. I think Spectre is going to be dependent upon whether someone out there really and truly can write some super awesome code to take advantage of it. Because I'm sorry, branch prediction is still pretty rarefied territory. And you have to really and truly know microcode really well. Right. To be able to go and start taking advantage of the stuff. Yeah.
Whereas,
so I think
anyone with a Metasploit toolkit who has access to kernel memory can do something really bad. So yay. I'm with you. I think Spectre is bad because anytime you're messing with branch prediction, it's bad. But and this has been echoed in the chat room by Rorks and a couple of others. Meltdown seems like the one that's got more legs. It's got more immediate impact. It's bigger. It has more potential for damage. So we'll see. We're going to be coming back to that in a while, but I do want to get to our guest because we got to talk about all things IBM. That's right, IBM, International Bitcoin Machines. I think that's about right. We welcome to the show Mr. Jason McGee. He is the Vice President and CTO of IBM Cloud Platform. Jason, thank you very much for coming on to This Week in Enterprise Tech.
Thanks for having me.
Now, of course, I made the little pun, International Bitcoin Machines. International Business Machines has been around literally since the start of this industry, and so we have a great debt to IBM. But before we jump into your spiel, can we talk a little bit about what IBM is doing with the blockchain? You've done some incredible strides that I think very few people actually know about.
Yeah, absolutely. I mean, you know, IBM has focused on enterprise workloads for a long time, and we saw early the impact that blockchain would have on business processes, on industries like financial services and travel and other places. And we've been doing a lot of work to both evolve the technology, like the work we've done with the Hyperledger project and Apache to, make blockchain technology available and open source so that developers could start building apps. have been doing some really interesting work with our customers on kind of applying blockchain technologies to their businesses, like work we've been doing with Maersk, for example, on shipping. So a lot of interesting activity on that space.
Now, let's go to cloud platform, because that's your department, that's what you're in charge of. And a lot of people, when they think of cloud platform, they're still stuck in the old idea of, oh, it's you take all your infrastructure and you put it in the cloud. And right. Yes, okay, that's true. That does happen. But I think IBM is one of the pioneers in actually putting the value add on that. And that is, it's not just taking your infrastructure off your campus. It's giving you an intelligence, the features of an intelligence that you can't get just by moving your equipment. Tell me, what is IBM's vision of cloud?
Yeah, sure. And you're right. I mean, if you look at a lot of IBM's history in the enterprise space, it's been around applications. We help enterprises build their applications. And, my personal history is all in the middleware space. I did things around Java and application servers with WebSphere for a lot of years. And so as we approached cloud, we always from the beginning had this notion that a cloud platform, while at its foundation has infrastructure, of course, has compute, storage, and networking that is accessible through APIs. The real valuable part would be, what can we provide for developers who are building applications on top of that platform? And developers, of course, they love hardware, but what they love even more is not having to worry about hardware and having higher level abstractions to work with. And so in the platform layer, we've really been focused on, how do we expose to developers things like containers and microservices and compute platforms that are more tailored for web app development and APIs, and how do we provide data and AI capabilities as APIs that those developers could use. So really trying to build out a rich platform of platform services for developers to build those apps. And that's been part of our strategy from the beginning. Of course, with an enterprise slant, we really think about security and availability and performance and the things that enterprises care about as they look to adopt cloud as part of their application landscape.
Now, when you think of IBM Cloud Services, of course, your mind has to wander to Watson. Watson
Sure.
captured our imagination all those years ago, and then it became something else. I mean, we've all seen the commercials, so we know IBM is about intelligence. We get that. Watson is about intelligence. It's about gathering together the various disparate data sources that you have and turning it into something actionable. But, I mean, how do you describe Watson to someone who doesn't really even understand cloud? Because it's a different product category, and it's very difficult to try to shove it into the categories that we think exist.
Sure. In fact, I actually find that describing Watson is easier than describing cloud to the average person, in the sense that, Watson is about how do we take data and information and gain insight and intelligence out of it, and how do we have systems help us, augment us in making decisions. What we've tried to do with Watson, I think, is really interesting. Obviously, machine learning and AI are really hot topics in the industry in general, and lots of people across the industry are working on that space. What we've tried to do is, I think, two things. One is, how do we take those techniques and apply them to specific industries? And you see that in examples like what we're doing with healthcare, with cancer research, and providing tools for doctors to help them understand cancer treatment plans and diagnostics around cancer. You see that in what we're doing with customer support and service, helping the call center you call into have better data available about customers. So we've taken these techniques that we developed in Watson and applied them to industries. But we did something else, which I'm really excited about, which is we delivered Watson on the cloud, and we exposed those fundamental capabilities of Watson as APIs that developers could use to add cognitive capabilities, to add intelligence to their own applications, so that we become a platform for people to learn and experiment and develop this kind of next generation of apps. And there's some really powerful tools there. I mean, I myself have built capabilities to, for example, add live image recognition of people to drone footage. So like in literally a weekend, I can take my drone, feed live video data off the drone to Watson, and have it detect objects and people that exist within all that footage. And as a developer, I can do that literally with a couple API calls on the weekend. 10 years ago, you could never do stuff like that. You would need a whole, data center of your own to run machine learning algorithms on. So I think this idea of taking Watson and exposing it as APIs on the cloud is really powerful. And it's one of the real reasons that people come and use the IBM Cloud.
Now let's talk a little bit about that, because it's one thing to talk about the intelligence. It's another thing to take a non-10,000-foot view of exactly what that entails. Guide me through how I would use the API. Let's say I've got my mythical 10,000-seat enterprise. I've got warehouses and warehouses of data about my customers, about my equipment, about whatever it is that I'm doing in the field. You come in as a consultant and you're talking to my developers and you're trying to extol the virtues of Watson, just as you did, but now you have to tell them the process. What do I have access to in your API? What kind of thinking do I need to have so that I can actually look at the data I have in storage and say, this is data that I should push to Watson because it will tell me something that I don't already know?
Sure. So there's a couple of maybe dimensions there to touch on. I mean, obviously, doing these scenarios that we're talking about require data, right? They require information to learn from so that we can inference what might happen in the future or answer future questions. The first place everyone has to start is, what questions are you trying to ask? What information are you trying to be able to determine? You have to kind of know what problem you're solving. Now, one of the approaches that we've taken in Watson with our cloud platform is, of course, we train the machine learning models on data sets. And there's lots of public data sets. And we've, of course, trained on public data sets like image data and speech data. We also have, as part of our cloud platform, unique data sets that we've acquired or developed, like health data, anonymized patient record data, or, a few years ago, we acquired the weather company. Part of the motivation there was, access to a lot of weather data that can feed these models. So you can think of Watson as starting out having been trained with common information for a number of industries. Of course, what most businesses want is they want to understand something about their business. So you have to train Watson or Delta train Watson with additional information about your business. And one of the things that IBM does very differently is we don't view that additional data is data that should be shared or combined with others. So your data that you use to train Watson for your specific questions remains yours. It remains private to you. It's your intellectual property. It's your competitive advantage. But you can take that data and train Watson with additional information about your customers, your products, your support issues, whatever it is, that makes sense in your industry, and then use the APIs to do sentiment analysis, to do comparisons of different trade-offs or decisions that you might make, to do image or speech processing, to generally explore and discover on that data. And so the process is basically, one, understand what problem you're trying to solve, two, ingest and train Watson on additional data. And we have a whole suite of tools as part of our cloud to help you with that data pipeline and ingestion and training process. And then three, use the APIs in Watson to then ask questions against that data that you've trained the models on so that you can expose that to your users and applications. And how you surface that to a customer is frankly up to you. And part of the power of IBM Cloud, the part that I personally own is, a little bit below Watson in things like containers. I provide the application platform that you would use to build microservices to call Watson and access that data and expose it to your users.
Let's talk about microservices, because the definition of a microservice can change from vendor to vendor. What is a microservice under IBM's umbrella?
Right. So the way I always think about microservices when I talk about it is first to say microservices has nothing to do with technology. It is not a library or a specific kind of technology. It's an approach to how you organize teams of people so that they can get work done. And one of the continual pressures in IT is, how do I deliver more quickly? And how do I respond to changes more quickly? And what many of us have realized is most of the inability to respond quickly comes down to people, not technology. It comes down to how people work together and how their work gets combined to deliver an end solution. And so for us, microservices is first about, how do we help people think about how they do development, how they break up problems into independent pieces. technology then supports that organizational style. And so in our strategy, we look at compute platforms like containers as being really critical to help those small development teams be efficient about how they package and run software. And we look at higher level capabilities around how do you govern and control how services talk to each other. And so we're really thinking about how does cloud act as an enabler, as a set of tools to help a development team adopt the principles of microservices so they can deliver things more quickly.
I think this is a good time to bring back in my co-host Chibert, because he's I can see him in my preview monitor. He's kind of bouncing up and down. I know that he's got experience with microservices, and I know that he wants to dive a little deeper into IBM's approach. Chibert, what do you got?
So whenever you start talking about microservices, I keep hearing it from the development side. Sure. I don't hear a lot from the operations side. Microservices, I'm used to things like EM7 or something like that, a nice operations system for your NOC. What kinds of challenges do microservices bring onto the operations side of the shop?
Yeah, it's a great point. And you're right that maybe me and lots of other people talk about it from a developer perspective, because in a lot of these microservice teams, the development team is really a end-to-end team that owns that service, including operations. So it kind of blurs together. But you're right that there are, of course, unique challenges with microservices. And in fact, one of the things that I think isn't maybe obvious to everybody is microservices is actually making a very explicit trade-off. You're trading off improved velocity around development in exchange for much more complex operations, right? Because in a microservices model, you might have hundreds or thousands of components that are interacting with each other. That's a lot harder to operate than a big monolith that you have 5 copies of running, right? And so there are some unique challenges around how do I manage security in that environment? How do I understand what's going on? How do I do resiliency testing? One of the things that IBM did in collaboration with Google is we launched a project last year called Istio. And Istio is an open source project that its mission is really to help provide the tools for that operational problem. How do I control the flow of traffic? How do I roll out new things into production? How do I test new versions? How do I resiliency test the failure behavior of an application? How do I get telemetry about what's going on in a complex, microservices environment where I have hundreds of components? So I think you're right that space is really important, and mass market adoption of microservices as a technique will depend on having good tools for the operations team or the operations role, whoever has it, to be able to get a handle on this more complex environment.
Okay, well, let's talk a little bit about that, because I've always had that question. I understand the efficiency that you can gain with microservices. I understand when you start connecting everything with APIs, you make it possible to roll things out more quickly, giving individual applications to different development teams. That all makes sense to me. But like you, I'm wondering, how do I test that? When I've got so many moving pieces, when I'm moving from the monolithic suite of tools to literally dozens, if not hundreds of applications, all developed by different teams connected via API, what's the best practice for testing that? I mean, security-wise and performance-wise.
Yeah, it's an evolving space, right? And I think there is new technology innovation needed to make that easy. One of the things I think will make that problem solvable is that these environments now, with things like containers, what we've done is we've standardized both the software packaging and the kind of runtime lifecycle of software. We've made it more common, but we've also generated very metadata-rich environments. So there's a lot of information available about the software that's running in this, in this kind of microservice environment. And with tools like Istio, we actually have visibility into all the network communication happening between the microservices. And so I think the testing stuff, tools like Istio will help give us some of the primitives. Like I can do things like failure injection or delay injection. I can say between service A and service B, introduce some artificial delay so I can understand what the behavior is when the network slows down or when somebody doesn't respond properly. So it gives you a lot of the tools you need to be able to do testing. It's still hard though, right? I mean, if I have 1,000 things, like sitting there tweaking all the timeouts to figure out what's going on is still time consuming. So I think there's a big emerging opportunity for applying machine learning to that metadata and to those tools so that we can take tools like Watson, use them to actually learn about the operational behavior of a microservice environment, and then use tools like Istio and Kubernetes to introduce controls like change timeouts, reroute traffic, and generally understand the behavior of those applications. So this space is really exciting because I think the core tools are there to be successful with microservices, but the kind of mass market tools to let everyone in the industry be successful at it are still emerging, right? But they're emerging really rapidly. And so I think 2018, for example, you'll see a lot of progress with some of these projects enabling, the average enterprise development team to be successful at these approaches.
Okay, so I've got to ask, when I started, poking around on your site, you guys have some really interesting little bullets, and I think the one that really caught my mind was remove silos. And it says collaborate with confidence between teams from data scientists to developers and across technologies from cloud to data science experience.
Sure.
So let's dive into that just a little bit.
You want me to analyze our marketing? That's awesome. I think the idea there is, maybe goes back to some of the first comments, which are, the way cloud has evolved, it started out as a very infrastructure-centric thing. But the approach that we've taken is a little bit more holistic, right? Where we've thought about the full stack that's needed to run enterprise software. And implied in that full stack, from infrastructure through the platform things that I've been talking about to data and Watson, is different roles, right? Different roles, and in most companies, different roles like data scientists versus developers versus network engineers are different organizations, right? And what we've tried to do is, as we've designed IBM Cloud, we designed it to have all of those roles participate together in a single experience. So you come to IBM Cloud, you not only see the tools for all those roles, but there's data sharing between those roles, there's permissions and communication between those roles, there's an ability to collaborate between those tools and to share data between those tools, whether that's IT data like logs and metrics, or whether that's data models. So I can have a data engineer create a data source and then expose that data source easily to a data scientist who wants to use Watson to do exploration. And so this idea of having an integrated cloud platform enables those roles to work together in a way that wasn't true in the past. Like in traditional enterprise IT, each of those teams used different software that was deployed in siloed environments with no necessary connection between them. And cloud enables us to start to eliminate those silos, those boundaries between teams, and let them collaborate more easily.
Jason, I've got a question. Let's say I'm running a more traditional enterprise and I'm just starting to migrate my infrastructure into the cloud, and I start hearing about microservices, and my IT guy is coming to me and saying, well, we should start thinking about this. What changes do I need to make on my internal team that has been developing huge applications over the course of decades, where I'm now going to say, well, instead of one big dev team, I've got 40 dev teams, and each are responsible for this little bit and piece of an app that they need to create, following the rules of the API. What are some of the biggest mistakes that you've seen when companies move into that? And then what are the ways that they can avoid those mistakes?
Yeah, that's a great question. So I think there's two big mistakes that they make. One is not changing the org at all and trying to approach these techniques. There are changes in how teams work that have to be adopted. And the second mistake they make is doing it all at once. Looking at their big environment and saying, okay, well, I'm going to change this from one monolith into 40 microservices and create 40 teams and do that all on day one. Because that's just not going to be successful for most people. You got to start somewhere, start small with one or two services that extend or add on to the side or change some component of an application that you have today. But for that starting point, yes, you have to build a team that can own that service end to end. I think one of the really important ideas of microservices is that the team that owns that service owns the entire life cycle of that service. They build it, they test it, they deploy it, they operate it, they can change it whenever they need to change it as independently as possible from everything else going on around them, which is why things like APIs are so important. I look at ourselves. I mean, IBM, we're pioneering a lot of these ideas, but we also apply them to ourselves. And, we're a big enterprise that's been around for a long time. So we have a lot of the same transformation challenges that a lot of our customers have. And one of the first things we did in our journey around IBM Cloud is we created a new model in how we organized our teams. And we created what we call tribes and squads that was modeled after how Spotify does their development. And the idea with tribes and squads was exactly that, to have co-located teams that owned a service end to end, right? And that was not how we were organized before. And that's been, I think, really critical to being successful. So when I go talk to clients, we talk to them not only about our platform and our technologies, but also how they can transform their development practices to be successful in exploiting these things.
All right. Cheever, is this something that you would use on your campus? Because, I mean, it sounds like it's right up your alley.
Yeah, actually, I've got a problem that I've got more data than I know what to do with. So that's one issue. But I've got hundreds and hundreds of hours of streaming video coming off our subs, our underwater cables, and our ROVs. And we'd love to have a way of recognizing species, but also making it so that we could have different research groups do different types of analysis on the data that's coming in, both acoustic and video. So I guess the question is, from that kind of standpoint, what kinds of things do I need to start looking at to try and adopt microservices? And more importantly, how do I integrate, say, Watson in there to do things like fish, oceanographic species identification from my video streams?
Yeah, it's a great scenario. And in fact, one that we've felt is, really fertile area for applying Watson. We, in fact, have a video unit as part of IBM Cloud that specifically enables kind of live streaming and video applications as part of our cloud platform. And one of the things we've been doing is exactly what you're describing, which is applying some of the image and video recognition capabilities of Watson to those video applications. So we can, you can do simple things like auto tag videos with what's in them, what kind of objects and stuff, so you can do better search. And that's all trainable. Like we have a customer who's doing something similar to what you're describing, which is they're using Watson to do maintenance of cell phone towers. So instead of sending a person to climb a tower and determine if there's any maintenance issues with that tower, they're flying drones around the tower, doing live video streaming off of the drone, feeding the video streams to Watson, and they've trained Watson with imagery about maintenance problems. Like, this is what rust and maintenance faults in these towers look like versus good towers. And that enables that application to automatically identify towers that might have problems without having to send people up there. And so I think the scenario you're talking about is similar, where you could take those video streams of underwater imagery, train Watson on species that you know about, and have Watson identify those species, or at least identify interesting segments of that video that would have further analysis. So, those are great scenarios that, these platforms are designed to help you build. Right?
I think that clears it up for a lot of our audience there, then, in that the applications for which microservices are best are those applications that deal with very complex problems that can be broken down into small component pieces. Anytime you can do that, that's a natural fit for a microservice.
Or an application that's changing a lot, right? Precisely. One that has a high rate of change.
Precisely. Well, that's a very nice way to look at it. And you know what? It's nice to have someone who can come in and actually explain something that has been a buzzword for a lot of people. And microservices now is what cloud computing was 5 years ago. And it's not going to go away. So thank you very much. Now, Jason, unfortunately, we are running out of time. But I do want to give you a chance to directly address our audience, because we've got people out there who are listening right now who are CTOs, CIOs, IT workers, who are looking at this and thinking, okay, maybe it's time for me to move to microservices, or maybe it's time for me to start leveraging microservices more heavily. What would be your elevator pitch to them? If you were going to be speaking on behalf of IBM, if you were going to try to express to them the special sauce that you think IBM has that no one else does, how would you pitch it?
Well, I think we've talked about a lot of those ideas already. Start with your applications. IBM's, secret sauce is that we actually understand enterprises and we understand enterprise applications. And a lot of those people are running apps that we helped you build. And we've built a cloud platform that enables you to explore both these new ideas like microservices and the existing stuff that you have and bring it into a cloud paradigm. So, what I would encourage you to do is understand the ideas of microservices. We have things like reference architectures as part of IBM Cloud that can help CTOs and CIOs understand the concepts and the components that make up microservice solutions, and come try it. The thing that I always encourage our customers to do is come to the cloud and try it. One of the great things about this era that we're in cloud computing is that it's basically free for you to come and explore these ideas. It's not like the past where you had to make a big commitment. So go do it. There's lots of ways that we can help you get started to explore these spaces.
We've been speaking with Jason McGee. He is the Vice President and CTO of IBM Cloud Platform. Jason, thank you so very much. I'd love to have you back on the show at some point when we can put you with a panel, because we've been looking at those types of episodes where we can sit down our gurus, our experts, and just have them go at it. Would you be willing to come back onto This Week in Enterprise Tech at some point in the future?
I would love to.
Fantastic. And if you could, one last parting shot, tell the folks at home where they can find you, where they can find IBM, where they can find Watson, where they can find more information about what you can do to help them with microservices.
JR McGee on Twitter or IBM.com/cloud.
Jason McGee, we thank you for being part of the Twilight Riot.
Thank you.
Folks, you've done it again. You've used up another hour listening to the best dang enterprise podcast in the universe. That's according to 9 out of 10 microservices. I want to thank everyone who makes this show possible. Of course, to Jason, our guest, for coming in and dropping knowledge on the Twilight Riot, but also my co-host and my friend, Brian Chi. And Chibert, I got to say, we missed you the last month, but it was nice knowing that you were out on vacation. It's good to have you back, my friend. Where can people find you and your work?
Well, obviously, I listen to the folks on Twitter. Otherwise, I wouldn't be giving JJ to the 4884 comments. I'm ADV, NETLAB, Advanced Net Lab on Twitter. But I'm also Chibert at twit.tv. If you have show ideas, or if you have particularly interesting people you think we ought to have on the show, feel free to toss me a line. Again, that's ADV, NETLAB on Twitter, or Chibert at twit.tv. So be there, be square. Give me information. We are scheduling like you wouldn't believe, and other than having to shuffle a few shows around, we are actually got schedules out into March now. So,
Chibert, thank you as always. Thank you again, and also thanks to you, to the people who watch and listen each and every single week. Without you, we wouldn't have a show. We want to make it a little easier for you to get the content that we create each week. Just go to our show page at twit.tv/Twiet. That's TWIET. This Week in Enterprise Tech. There you'll find all of our back episodes as well as the notes for every episode. If you want to know the news stories that we covered, we'll give you the links. If you want to know the contact information for our guests, we'll give you their contact information. And more importantly, if you want to support the show in the best way possible, find the little menu for subscribing. That's right. You can get an audio version, a video version, or a high-definition video version automatically each week into your device of choice. It's the best way to share and the best way to make sure that we can continue doing Twiet into the future. Also, don't forget that you can find me at my Twitter page at twitter.com/PadreSJ. If you follow me there, you find out what I do when I'm not here at the Twitch studio, as well as what technology projects I may be working on at that particular moment. Also, thanks to everyone here at the studio who makes the show possible. Of course, to Lisa and Leo, who have allowed us to do This Week in Enterprise Tech all these years. To our fabulous engineering crew. And, of course, to that special person, my technical director, Kevin the Shark. Kevin, this is the time of the show where we ask you a question to give you a possible redemption for all your wrong answers in the past. So I'm going to ask you a super simple question. What does ASLR stand for?
Animal species living.
No, I'm sorry, Kevin. Of course, we were talking about the Intel and AMD processor. ASLR is address space location randomization, but maybe you'll get it next time. Until then, I'm Father Robert Ballister, the Digital Jesuit, just reminding you that if you want to know what's going on in the enterprise, just keep quiet.